In this video, I'm going to try to motivate the study of complex numbers by explaining how we can find the square root of a negative number. Before we do that, let's recall some facts about real numbers. On the diagram here, I've drawn what we call a real number line, and every real number has its place on this line. Now, I've marked the whole real numbers from -9 up to +9. So all the positive numbers are to the right-hand side, the negative numbers are to the left-hand side. Every real number has its place on this line. So the integers, positive integers, negative integers are here. We can also put the fractions on as well. So for example, the real number -1/2 would lie somewhere in here. Decimal numbers like 3.5 would be somewhere in there. And even numbers like pi will have a place somewhere in here as well. So pi is going to be in there somewhere. So the point is that all real numbers have their place on this real number line. Let's look at what happens when we square any real number. Suppose we take the number 3 and we square it. When we square 3, remember, we're multiplying it by itself. So 3 multiplied by 3, the answer is 9. What about if we take the number -3 and square that? Again, when we square it, we're multiplying the number by itself, so it's -3 multiplied by -3. And here, if you recall that multiplying a negative number by a negative number yields a positive result, the answer -3 times -3 is +9, positive 9. Now the point I'm trying to make is, whenever you square a number, be it a positive number or a negative number, the answer is never negative. In fact, unless the number we started with is 0, the answer is always going to be positive. You can't get a negative answer by squaring a real number. Now, over the years, mathematicians found this shortcoming a problem, and they decided that we'll try and work around that by introducing a new number, and we're going to give this new number the symbol I. And I is going to be a special number that has this property that when you square it, the answer is -1. So I is a special number such that the square of I squared, is -1. Now that clearly is a very special number because I've just explained that when you square any positive or negative real number, the answer can never be negative. So clearly this number I can't be a real number. What it is it's an imaginary number. We say I is an imaginary number. Now that might seem rather strange when you first meet it, starting to deal with imaginary numbers, but it turns out that when we progress a little further and we do some calculations with this imaginary number I, lots of problems in engineering and physics and applied mathematics can be solved using this imaginary number I. Now, using I, we can formally write down the square root of any negative number at all. So supposing we want to write down an expression for the square root of -9, the square root of a negative number. What we do is we write the -9 in the following way. We write it as +9 multiplied by -1. And then we split this product as follows. We split it as the square root of 9 multiplied by the square root of -1. Now the square root of 9 we do know, the square root of 9 is 3, and the square root of -1 is going to be I, because I squared is -1, so I is the square root of -1. So in other words, now we can formally write down the square root of -9 as 3 times I. Let's give you another example. Supposing we wanted the square root of -7. We do it in exactly the same way. We split -7 into 7 times -1, and we write it as the square root of 7 multiplied by the square root of -1. Now the square root of 7 we can't simplify, we'll just leave that in this so-called surd form, square root of 7, and the square root of -1 we know is I. So the square root of -7 we can write as the square root of +7 times I. So the introduction of this imaginary number I allows us to formally write down an expression for the square root of any negative number. Now, using this imaginary number I, we can do various algebraic calculations just as we would with normal algebra. Let me show you a couple of examples. Supposing we're asked to calculate I cubed. Well, I cubed we can write as I squared multiplied by I. We already know that I squared is minus 1. So I squared becomes minus 1 multiplied by I, which is just minus 1 times I, or minus I. So we can simplify the expression I cubed in this way, just to get the answer minus I. Let's look at another one. Supposing we have an expression I to the 4. We could write that as I squared multiplied by I squared. And in each case, I squared is minus 1. So here we have minus 1 multiplied by minus 1. And minus 1 times minus 1 is plus 1. So I to the 4 is plus 1. And in the same way, we can start to simplify any expression that involves I and powers of I. You'll see this imaginary number I in lots more calculations in the following videos.